So, what's up, everyone? For guys and gals who want to get into Kubernetes, I feel like this is going to be one of the best places. You coming to this video, I think you might have read this file. If not, please do link. Please do read this file. I'm gonna link everything down in the description below. This file, the GitHub repo, everything. You should just go through this. For anyone who's new to Kubernetes, or let's say anyone who's already wrapped their heads around Docker, getting into Kubernetes, I think this is a good place. I myself have just, started Kubernetes, and, I thought, why not make something cool? So this is the place. Now, this is the video to actually reproduce this entire project from scratch using the README, using this README and using these steps, right? And we're gonna reproduce this entire project. I'm gonna start over with a glimpse of this project, and then we'll get into just making this come online. So starting off with GCP, basically I've got these 3 steps to deploying any particular code, right? Any particular container. Step 1, make images. Step 2, all you gotta do is just push these images, usually gcr.io, but GCP was saying that they're gonna make a new, we've got something, I think there's a new convention for artifact registry. So you might want to look into that, but I guess this is the old and the most stable method, but they're saying they'll replace this part of the pipeline. But anyways, yeah, just make images, push images, and you've got YAML files to sort of make running instances of these images in form of pods, or or so to say deployments or services or config maps, secrets, ingress, anything like that, right? So basically making running instances of these images. You might need an image, you might not need an image, but basically these 3 steps, right? Make image, push image, and use the YAML files. And inside these YAML files, we've got the path of this image. So these YAML files use the image and, make pods or make these reproducible instances of running code, right? So that's the basic pipeline. And if you want to go a little bit further, you can also see that the same 3 steps, make, push, and use, is condensed into this one cloudbuild.yaml file. Right? So you might have a repo having a bunch of code which you run to get its running instances called containers in Docker or pods or services or such in Kubernetes. You can have that code here in a repository, and then you can have a condition to trigger to run this cloud build file, right? So this is the master card that you have, right? This file, you run this file, and this file is basically containing of the same 3 steps that I told you, right? Which basically is make, push, and use the images, right? So, but this doesn't simply run, right? This doesn't run. It can run on schedule, it can run on push. It needs a condition to run. It doesn't run indefinitely. It needs a particular condition to run, but basically a repo, a cloud build file, which could be on your repo, off your repo. It must be somewhere on GCP or on repo, and there's GKE cluster. So when you play with these things called pods and services, or these running instances, when you play with these toys, you're gonna have a playground, and that playground is GKE cluster. That's the Google Kubernetes Engine cluster in GCP. So this is also a very integral part of this entire pipeline. If you really want to get into what is a service, or anything like that, I would say that please read this file if you want to understand more about KSAs and GSAs and how these basically different things work. In brief, the GCP, Google Cloud Platform, is containing a bunch of things like buckets, like databases, like different kinds of service accounts in GKE cluster, and they've got the equivalents of Lambda functions, in Cloud Build is in GCP. So you've got a bunch of things, right? And to use these different services in GCP, you need something called the GSA. And this is the GSA. And GSA is a Google Service Account. It's basically like a IAM role or something that gives you certain permissions to use certain services. That's GSA basically. And one of those services is GKE. That's your Kubernetes. That's the playground, right? So you've got a MasterCard that gives you permissions, and you've got a playground. And within this playground, if some things, let's say I've got a pod in here somewhere that wants to communicate with something outside GKE, right? So like, let's say storage buckets or something. So technically you have the entire GCP, and within GCP, you've got GKE clusters, you've got storage, you've got databases and all those things. And let's say something inside GKE wants to talk to something like, let's say, for example, the buckets, then you'll need something called KSA. Basically, it's the equivalent of GSA, but inside the GKE cluster. So this is like a local card, right? This is like a local card, and this is like a global card. And this local card can give permissions to play inside this playground. But if someone wants to talk to something else outside this playground, they need permissions given to them by GSA. It's that simple, right? So GSA is the MasterCard for permissions to GKE, to different kinds of services like buckets, databases, and KSA is the local card to play inside this playground. And if something inside this playground wants to talk to outside this playground, it needs permissions that are there with GSA, but not with KSA, right? And these steps and everything, I'm not going to go in detail of all this. Please, 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 I will say read this file and look at the repository, look at the codes, right? And I'm sure there are going to be some errors in the code as well, and I'll be happy if you call them out, because it's all a part of learning anyways. So yeah, so technically, if you want me to give you just a gist of this project, I have a repo, and we've got a web code, right, for website, and then we've got an ML code that takes care of ML models and predictions and all those things. So we've got an ML code and we've got a web code, and all of this is there inside repositories. Obviously, we've got different folders for ML codes, different folders for web codes, and all of these folders are together like with each other. But then we've basically made two separate pipelines, one for web and the others for ML. It's as simple as that. And so the idea is, let me zoom in. So the idea is we've got a GKE cluster and we've got two namespaces to keep things to keep the things separate logically, right? ML and web, right? This is called a namespace ML, and this is called a namespace web to keep things separate, right? So we've got a playground, we've got two sub playgrounds, right? One is for, let's say, basketball, and the other for football, or whatever analogy you want to use. But basically, we've got web and ML. And we've got a MongoDB that's totally outside GCP, right? You've got a URI and you can sort of connect to this data, but this is not a part of GCP technically. And so the idea is you've got a web app that runs your web interface, like /predict endpoint /index / just this normal root endpoint. So it basically runs all the endpoints and basically gives you the HTML object, right? The string, using render template. That's how web app works, right? It's basically just for web. And if it wants to store something into MongoDB, it hits the DB app. And the DB app then stores, right? Its sole purpose is storing. So we've got DB app for storing, web app for web. And we've basically got an ingress of like a web server, web app ingress, let's call it web app ingress, that gives us an external IP. And each of these pods basically have different kinds of services, right? So for example, this pod cannot talk to this pod, or this pod cannot talk to this pod. This pod cannot talk to this pod. This pod can only talk to the service, and the service is binded to this pod, right? So if this pod wants to talk to this pod, right? So basically, if this pod wants to talk to this pod, it basically hits the service, right? And automatically it reaches this pod. That's how it works. And yeah, so you've got something called confmap and secrets. So for example, if you want to inject variables, or let's say you want to change some dynamics of this entire playground. For example, you want to change the amount of goals in the playground, or let's say if you want to change the amount of players in the playground, whatever, right? So basically some variable that you want to change, you put all of those variables into confmap. Conf map is like the dynamic variables, right? It's basically storing all the dynamic variables in one place, and all these different pods that you see can use the conf map and get those variables. It's as simple as that. And secrets, on the other hand, is basically just URIs, usernames, passwords that these pods will want to use. And these are cron jobs, right? So, I've given a naming convention. Again, I would say please read this PDF. But this is a cron job. So a cron job is basically like a template with a job template and a schedule, right? It's a template for a cron job. Technically, we look at the code. I've set everything up. If you want me to show, I'll just show you the whole damn code. Code is I'll just show you the code, right, which I have with me right now. So I was talking about, what was I talking about? Yeah, I was talking about cron jobs, right? So for cron jobs, if you look at it, cron job is, I'm just diving right into the code, but this just to give you a perspective, a cron job is a schedule with a job template. It's basically nothing but a schedule with a job template. And on the basis of this schedule, it triggers this job template and create a job out of it. It's basically like a temporary pod that dies after everything is run inside it. Everything is completed running inside it. And this part right here is a template for the job, right? The template of the container that the job has. Get it? That's the job template. So it's basically a schedule with a job template, and it basically spawns a pod. So technically, all of these pods that you see right here, they're continuously running. If you've got a pod that if you basically want a piece of code to run every 3 hours, you put it in a job, and it's managed under cron job. That's the idea. So this is a cron job, and you've got services, you've got cron jobs, you've got pods, you've got secrets, conf maps in both the namespaces. These right here are buckets. We can set them up to store something. They're like bins, right? They're basically like bins to store your stuff. With folders, they're basically like a directory, right? And any of these folders that you see, this could be a bucket, right? So it's as simple as that. And you've got an ingress. Ingress is basically like an HTTP server. Just if you can have type nginx, or it could be just normal ingress flavor, whatever, right? And the way all of this works is the user uses this public IP to hit the ingress, the HTTP server, and you get the web app. The web app then returns a page that asks for certain data on the basis of which to make prediction. The downstream task that we've got is your house price prediction. So you'll be able to fill in different things like the number of floors, the square feet, and so on and so forth. Then using this public IP, we give the data to predict the price. Then it hits the MLApp service, and the MLApp has loaded the model from MLFlow server, the best model according to whatever accuracy. So it's basically, we've got experiments and runs, right? We've got something called experiments and runs. So it goes through all the experiments, all the runs, checks the best accuracy, looks at the registered model. For each of those registered models, it says which one matches the accuracy that it just scanned, right? Let's say if the best accuracy in all the runs is 97%, it simply goes through all the registered model, matching them with the run ID of that 97%, and then takes the best model and loads it up in MLApp. And so this MLApp gets a request with the data. It gives back a prediction. It stores the prediction. It hits the DB app to store the prediction in the predicted prices table, and then just simply renders the prediction, right? But since this entire setup is an evolving setup, you can sort of change the predicted prices and you can correct it. So you can again give the corrected price, and web app will again hit the DB app to store it in the corrected prices. And things from the corrected prices will be feeded back, right? It'll be feeded back into the training of the model. And on namespace ML side, so the idea was I'll make a folder called models, and you can simply add. So for example, if this is the folder models, where is it? Yes. So if you wanna, so right now this model folder has a subfolder linear_regression, meaning your this project currently supports linear_regression, basically linear regression, right? And let's say tomorrow morning, if you want to use XGBoost or some other different kind of model, all you have to do is make a different subfolder, just like linear regression, just push it within this models folder, and everything will turn and twist inside this playground, and everything will come up online. Everything, right, including the new models, the old models, and we also made sure that none of the old models are, retrained on the same data, right? So no model is trained on the same data again. That's versioning. It's possible partly because of this MLFlow server. I'll get into detail, but then MLFlow server is doing all this stuff, right? It's storing models. It's recording that which model is trained till which version, and it basically registers the model. It monitors the various params. It monitors the various metrics. That's the job of the MLFlow server. We'll get to the working of this namespace, right? This playground in a while, but technically, the idea is that if you put another folder like linear_regression, let's say some other model, you put that folder into models folder, you push it with something like train.py. So that's basically like the retraining code, train.py, the Docker file, and the YAML file in KHML, right? The YAML file in KHML and an extra step in cloudbuild1.yaml. If those three things are satisfied, it takes into account the newer model now, right? Along with the older models. So you have two namespaces, two different divisions. One is for ML, one is for web codes, and two pipelines, and triggered by two Cloud Build YAML files. So Cloud Build 1 for ML, right? So this is Cloud Build 1 in here. And I previously just showed how Cloud Build sort of works, right? This is one Cloud Build to build stuff, right? The condensation of 3 steps. And so this right here, pipeline 1, is your Cloud Build 1.yaml, right? Which does 3 things: make the image, push the image, and use the image. This part is making the image. As you can see, it's build-t, right? It's /docker, and then build-t. These are Docker commands, right? And then the second step is push. So it's gonna push everything, right? So GCRI, just push it, right? Docker push this, right? And the third step, which is use, that is basically like applying a YAML file. So you apply a YAML file, and a YAML file could look something like this. A YAML file is this, right? You basically mention the name you give to the pod, the service account name. We'll get to that, but got something called service account name if you still don't know about service accounts. And this is basically the KSA name, right? And containers, and you basically mention the pod has what containers running inside and the image, right? So you run this YAML file inside this cloud build, and that applies, right? You apply this YAML file, and you've got everything up and running. As simple as that, right? So one YAML file for this one yellow box, and the other YAML file for this other yellow box. It's simple, right? And so how things work inside this namespace. You've got a conf map and secrets for this, definitely. Now you've got a model retraining cron job, right? It's basically a job that spawns every 6 hours, 7 hours, 6 hours, 7 hours, or you can set it yourself. And this cron job is the data collection and pre-processing and versioning cron job. So let's just start from the beginning. You've got bucket 1, bucket 2, and bucket 3. Bucket 1 is for developers, right? Where you can just simply give in data.csv inside this bucket 1. All right. And this data collection pre-processing cron job runs every 3 hours. It spawns up. It just simply spawns up and takes the data from this bucket 1 and takes the data from the corrected prices given by the user, pre-processes that, and puts it into bucket 2. And note, there's something called a variable. There's a variable set as batch size inside confmap1, and these are all dynamic variables, like I said. And then this is the batch size. That's a variable that's inside config map1, and that batch size is the one that it sees to, basically it sees whether you want to version this or not yet, right? So let's say we've got 30 rows from here, and let's say we've got 10 rows from here. So total 40 records, right? 40 records of data to be trained on, right? So the models can use this new 40 records to train. But the batch size says 50. So it doesn't version that into a newer version into bucket 2. So let's say bucket 2 has folders v1, v2, v3. It doesn't make v4, right? Because there are only 40 records. We need at least 50 records to make a version 4 in this bucket. And therefore, it just simply caches it inside a folder called stream or in stream, right? So technically, every 3 hours, this comes up, takes everything from bucket 1, corrected prices, pre-processes everything, and puts everything into bucket 2. That's all. And this code runs every 7 hours. It takes everything from bucket 2. It checks, first of all, it checks for its own model, right? So if this model is for linear regression, right? So if this cron job is for training linear regression, simply goes to the MLFlow server, looks at the experiments, which are obviously I've named, the naming convention is by the model name. So if let's say this is linear regression, it looks for the experiment linear regression in MLFlow server, checks the one that has the best accuracy, loads that model, and checks, we've got a tag trained till version. So it checks the tag for that model, and if the train till version is, let's say, 3, right, and then it checks into the bucket, and let's say the latest folder in the bucket is v5, then it basically loads v4 and v5, which are new data sets, and trains the model, logs the params, logs the metrics, and logs the model itself into MLFlow server. That's the job of this retraining. And MLFlow server, on the other hand, this is a stateful service. It's not a state. It's a stateful service, meaning if everything dies, let's say if this pod dies, which Kubernetes does often, when a pod dies or when it reschedules or when you do a rolling restart, rolling update or something like that, the pod dies. And if the pod dies, the models, the params, the metrics, everything dies inside it. So you need to attach 2 things. One is this PostgreSQL instance for metadata, meaning what are the different experiments, what are the different runs, and so on and so forth. And you have this bucket 3 attached to this MLFlow server. Why exactly? To store artifacts, right? It's basically a bucket. So now if this pod dies, right, things still remain inside bucket 3 and PostgreSQL instance, right? These 2 things. And by the way, these are GCP services. And like I said, if you remember the KSA and GSA concept that I talked about just 5 minutes back, you would understand that to access this, and to access this, and to access this, and to access this, which are different GCP services, you need KSA, and the KSA should be having the permissions with it, given to it by the GSA. Right, where is it? Yes, given it by the GSA. That's the way it works. And so there are 3 steps. Step 1, create the KSA. Step 2, you bind this KSA to GSA, but that's not enough. So step 3, the GSA from its own side authorizes the permissions. That's the 3 step. And as we'll see later in the implementation, the KSAs can be created either by YAML or by commands. And we are creating it by YAML file. So technically, when all of this comes up, right, when all of these cron jobs, pods, services, and conf maps and secrets, everything comes up, that time the KSA will also come up, right? It'll come online. And then you can sort of authorize and, it's called giving a workload identity from the GSA side of the case, and then you can do that, right, once everything comes up online, and then you can restart everything. So that's the idea. That's the original idea. The secondary part is to create a reproducible code, right? I've done my best to document things, but then once in a while things go here and there, right? Things mess up, and it's sort of hard to recreate things again. But I'll try my best, and let's see. So to make this project, you need 3 things. I don't know, I just simply mentioned that number. I haven't even counted yet. One is MongoDB, second is buckets, third is PostgreSQL instance, and there you go. The 4th one is GKE cluster, And the fifth one is this repo. So total 5 things, right? The MongoDB, we need buckets, we need this PostgreSQL instance, you need the GKE cluster, and the code, right? Additionally, we do need the Cloud Build YAML files, triggers, and what did I miss? And the GSA and the KSA. So that's the whole setup, right? We need MongoDB, we need buckets, we need PostgreSQL instances, and we need this GKE, we need GSA, we need KSA, we need the repo, we need Cloud Build YAML pipeline, and the trigger, and build. That's it. Boom, you just push, and so that's kind of the idea. Again, if I'm going too fast or if things look inscrutable or overcomplicated, you can always come back to this file. So the main idea is to reproduce the code. So let's just get on with it. So I have with me the, let me just, I'll just start from new one, right? I've got Google Cloud Console, right? I've got a new MongoDB setup, right? Yep. And guess what? I have credits, without which this wouldn't be possible. Yeah, I'm not using my own money. I've got $50. So this is a fresh account, right? I've got a fresh GCP account. I might have a second project. I've already got a project. We will create a new one, but it's a fresh account, and I've basically got MongoDB. All right, I'm gonna sign in with Google. Let's see. Yeah, it should work. Okay. So I've got this README file with the steps in here. All right, so I'm going to keep track of all of these steps, and I'll go one by one with all these steps. The second is I've got a fresh GCP account. I've got, it's not a fresh MongoDB account, to be honest. I've already got a cluster in here. So, you know, I've already got a cluster in here. So, but we'll start fresh, no worries. And I've got a notepad and VS Code, but I'll just go to a new one, right? I'll just, but I need to clone, so I'll just go to a, right? I'm just selecting a fresh folder, right? That's the fresh folder. Get it? So I've got VS Code, I've got Notepad, I've got fresh MongoDB and fresh GCP, right? And I've got an Notion file. So let's just start off with it. So these are the variables that you need to take care of. Step one, these variables are something that you need to take care of. So I'm going to put that up in this. All right. So these are the various variables. Second is set up MongoDB. So I'm going to log in to MongoDB. I'm logged in and chose clusters. I'm going to go ahead and browse collections and try and make a database, right? So to practice project database, you know what, I'll just go ahead and create a new database, right? Create a database. The database is going to be naming, I'll just name it demo, right? It's demo, and the collection is going to be my predictions. Does that make sense? My underscore predictions. Preferences none. I'm going to create that. And let's just store it up in here. This one is my underscore predictions, and my database is, what's the name? Demo, right? I'll have to create another collection in here, so I'll just go for my corrections. How about that? And I'm gonna say my corrections. Cool, done. Then this one says something about going under the network access tab and IP access list, right? So the, where's the IP access list now? Network access. Is that it? The IP access list. And it's already set to 0000, or you can just simply add, and it'll basically have an option just like add current IP address. We'll have another option over here. So you can just, you know, from anywhere, right? So add from anywhere. So you can just add that and you'll have this, includes your current IP address, whatever, right? 0.0.0.0/0 means from anywhere. And database users, I'm going to create a new user, read write any database at random. I'm going to create a new database user, right? And username could be, I am the new user, right? Password is my password. Cool. My password, and I am the new user. All right. Let's just store that. And so inside this Mongo URI, which we're going to create in a while, I'm just going to write it. I am the new user, right? I am the user and my password. Cool. And in a while, we'll just create this, we'll sort of make this Mongo URI. That's the idea, right? Add a built-in role. Yep. And we need read write to any database. Cool. Restrict access to specific clusters. Nope. Temporary user. Nope. I'm going to delete it, guys. So don't worry about this. I will delete it. Add user. So I am the new user and read write any action. That's the idea. All right. So database user setup, IP setup, and my database, which is inside my clusters. Okay. Come on, come on. One problem with this is very slow. Very, very slow. Why so slow? Just verifying. I already have things up. Demo my corrections and my predictions, right? Because one fault and this video is a waste. That's why. All right, on to step 2. Make sure to not include @ in passwords. I've taken care of that one. Create a project. Yeah. This one I already have. I'll just go ahead and create a new project. And you have 10 projects remaining in a quota. Yep. I'll call it, MLOps demo project. But to avoid any confusion, I'm going to keep this and this same. So it's the same thing, no organization. This is my project ID. I'm going to keep my project ID in this one. Cool. That's my project ID. Great. Okay, the project ID is created. And do we want to switch to that project or? Yeah, we'll just switch to that project. Cool. So now viewing this project. Cool. Step 3 done. Okay, stored the project ID successfully checked. Enable IPs, right? Go to the console right here. This is my Activate Cloud console. And now this is the API. Meaning to use Google Cloud, we need to enable APIs, right? So yeah, continue. It literally gives us access to various things like Cloud Build, buckets, and we'll be able to manipulate all of them from the shell. So that API is very important. Cool. Right, let's just run this. And run. It's going to take some time, and hopefully all of this will be done, hopefully, because you cannot really be sure about anything in Google Cloud. Some things might fail, and the same thing might work manually. So, and you'll have to set up a PostgreSQL instance. We're going to do that through the command line. We can do this with the, we normally do this as well, right? You can normally do this from here, from the UI. You can just search Cloud SQL, right? You can just search Cloud SQL. And you can create something from here, but then some people might have problems with default settings. So it basically asks a lot of questions in here. So you can just do it through the command and just specify the things that you need, nothing else, right? There's just literally nothing else. Hopefully this works. Do you want me to set up the names? That's cool. Google Managed Services default. So the idea is that your PostgreSQL instance that you'll be creating is managed by this guy, right? It's under the virtual VPC of this guy, right? And you will be in VPC default, right? So let me check it out. Okay, this thing has run, finished successfully. Let me show you something about VPC. And let's see which VPC are we inside. So my VPC, come on, off, irritating. VPC, VPC, VPC. So VPC networks is default. So we're in default VPC, and the PostgreSQL instance will be created in VPC of this. So we'll need to connect these two VPCs, and that's called VPC peering, and then you can sort of create a database that'll be accessible in VPC default. All right, let's just go back to the shell now. Enable a bunch of services again. So we're on to step 5 now. So one thing to note is zonal and regional. So regional is US Central 1, that's Iowa, and then zonal could be US Central 1A or B or C, right? And your PostgreSQL instance, we're going to make it regional, and then your cluster could be zonal. It could be a zonal cluster, regional cluster, whatever. But then I, in this README file, have followed the convention zonal, so I'll go for zonal. So that won't be a problem if your instance, your PostgreSQL instance, which is your database instance, is it's regional and your cluster is zonal. Cool. Now we're gonna make this, right? So Google Managed Services default, VPC peering. Can you create that, please? And then network is default. And I gotta change it in here. Yeah, it's a little imperfect, this README file, but yeah, you get the point. All right, done. And now on to this command. You gotta give this VPC name, right? So the VPC name, I'm gonna give it as default. Okay, this is logged. So I'm gonna go ahead, create a new file. I'm gonna give this as default. Cool. And go, right? Should work. So you're creating a VPC peering, and then you're saying that the server is this guy, the service networking.google.apis. Like I said, this guy, service networking.google APIs, this guy. Yeah, it gets connected. And we have not an error, right? Again, we give the network, right? And I'm gonna give it default. I'm basically just running commands, all right? I'm just changing VPC name with default, right? Hey, I think I did that once more, but okay, my bad. Now I'm gonna do this. This is basically like the verification step. This is default. Oh my God, sorry about that one. Yeah, let me check if it's already created. And it's created. Boom. Cool. Now we'll create a PostgreSQL instance name. I'll call it my Postgre. Yeah, you can call it whatever, but I'll call it my Postgre. My Postgre, right? And it's going to be in US Central 1 as a convention. The network is going to be default. And was an IP and CPU and memory. Yeah. Let's run that up. Yep, it's creating an instance. It might take a few more minutes, and just to get the IP, right? So it's my Postgre, just to get the IP, right, of my Postgre. It's working. And then a user and password. Again, make sure password doesn't have @ or your URI is done for, because this @ and the @ of the password would clash, and then you have to escape it with, I don't know what, with %40 or %50 or some sort of an escape sequence that will be found by going inside documentation of the URI. So that's, instead of taking the painful path, just avoid @ this simple rule. Cool. It is runnable, right? It has a private IP. Oh, I forgot to mention the conditions. The conditions are, it should be in the same default. It should be accessible in the default VPC, and it should have private IP access enabled. So this doesn't have a public IP. It has a private IP, and that should be accessible, right? Yep, with the help of a user and password of the database. Anyways, let's just. Right. That's the command to get the IP. And the IP is this. I'm going to store this. Or you know what? I'm not going to store this. I'm just going to start making the URI now. So the URI of PostgreSQL is to have this private IP and the port. This is the private IP. All right. And for the port, I think I forgot. It's usually 5432 or something. But we'll go to that. Right. Let's just do this now. Your database is going to be, we'll call it MyDB, and instance is going to be my Postgre. Cool, right? Now it's creating a database, and it is created. Now it makes a user. My user, this one is my Postgre, and password is my pass. Cool, 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 cool. Let's just store all of this again, because I'm not good at remembering stuff. My DB in my, where is the DB? It's MongoDB. Okay. Database name is right here. It's my DB and my pass and my user, right? So this is my pass and this is my user. Cool. The port, we'll get to it. I guess I forgot a step, to be honest, but it's okay. My user, my pass, done, right? SQL user creation, done. Now you're going to make this URI, and this URI is almost created, as you can see. Postgre, my user, my pass at this private IP / my DB. You've got the port. Let's get the port right. So like I said, you can just go to Cloud SQL in here. I like to keep things separate. So this, yeah, but it's okay. So this is my Postgre, and you can see the port is 5432. It's usually this is the default TCP port, right? So it's 5432. Cool, the URI has been created. Steps over. Now, step 6, to set up buckets. You just have to run these commands to make buckets, right? So just say, the project ID. So yeah, you need this project ID, right? Don't you? So why? The reason is the name of the bucket has to be universally unique. So for that, project ID is already unique universally. So it's better to follow this convention. Okay. I follow this convention, it's a healthy practice, or you can just go for putting random numbers like 1, 2, 3, 4 and such, right? That's the idea, right? Cool. And the location is a region which is going to be US Central 1 because it's a region, right? Cool. And I'm going to run one by one these commands. Bucket 1 done. Bucket 2 will be done. And bucket 3 done. Cool. You can go to bucket section in here, right? And see the buckets that you've created, right? These are the buckets that are universally unique names, right? Right. You use, so basically the codes and the processes use something called Google Cloud Storage to then connect to these buckets. Create a GSA, right? Which is basically the master card that I was talking about, right? That you have permissions and so on and so forth. And I'm going to call it my service account, right? My SA. It's a default name. You can just give any name, to be honest, right? Is my service account, and doesn't have the account ID, doesn't have a length. Cool. So I'll just you know what, I'm gonna unlock this page for now so I can start making changes directly in the Notion file, right? And so let's say this is my service account, or let's say my GSA account, right? My GSA account. Cool. Cool, right? Okay, this should work. And it's done. Add a policy binding. This service account. My SA. Nope. It's my GSA account, right? And I'm gonna give it roles of owner. Let's see if this is possible. Might raise an error, but I'm gonna give this GSA your active configuration as something. Why is my active configuration something? Am I in some other project? Okay, why is my active configuration cloud shell? The IAM policy for that is MLOps. Okay, seems fair enough. I'm gonna give it role owner, so I have done that. I really do want to store my service account name, right? Where is it? You can just go to service account. And that's your service account email ID. This thing that's just created my GSA account at MLOps demo. That's your project.im.gserviceaccount.com. I'm gonna copy that, and I'm just gonna keep it in here. I'll just keep it in here. Oh, by the way, I forgot to get the Mongo URI, so I'm gonna get that pretty quickly. All I have to do is just go to my project. Come on. And connect, and compass, or actually since it's a process, drivers, I'm going to get the connection string for this and done, right? Yep. And I'm going to make my Mongo URI now. Just something like this. And I think this was my Mongo password and user ID, right? I'm the new user. And this is my password. And this is to connect my cluster 0. Let's just check it out one more time. Right, I'm the new user. Makes sense. So in this, yeah. So this is the Mongo URI and my PostgreSQL URI. Both are constructed. My bucket names. I need to get my bucket names, right? I forgot that. I'm gonna go ahead and get my bucket names. But before that, so this is my GSA, right? And this is my project ID. Let's get the bucket names. Yeah, keep forgetting. So this name, right? It's this name that I need to give it my bucket name. It's 1, and it's 2, and that's 3. Cool. Buckets. Okay, all of this is done, and this is my G service account. All right, back to the steps. GSA created and service account configured for the owner role. Let's give it a bunch of permissions. Before that, we need to set the project ID. I guess I didn't set the project ID before giving the owner role, so I'm going to do that. My project ID is this. So these are variables, right? This is your value that you're setting. And this is your G service account. Cool. I'm going to set these up pretty quickly. And I'm going to run the owner roles again because I think I messed that up. So this should also come in here, right? Cool. Let's see. Service account, my GSA account, add config value, whatever. Right. Let's see if this works. And then it's this big code to give it a bunch of roles. So many roles might not be supported. Many are supported through the command line. Maybe I forgot to get an API, get a service up and running, a sort of an API. But most of this can be done manually. I'll show it to you in a second. Let's go to service account again. And this keeps creating the roles. Let me just touch upon a few roles, right? So for example, the log writer is to give the logs, right, which you'll get after triggering the cloud build. Work pool user cloud build. So that's to give the workload identity access to each of the nodes. Artifact registry, that's for pushing images as a part of cloud build. Create on push writer, so it creates that gcr.io. It creates the directory, right? Whichever directory wherever you're storing images, right? The gcr.io / whatever directory. And this one is for buckets, and this is for creating secrets, and so on and so forth, right? Still creating. So in here, if you look at it, come on. It's creating a bunch of services in here. Yeah. Name is my service account name. That's just the display. Permissions. So when you do manage access, all of this will come in there. And so Cloud Builder admin won't work because if it works, Cloud Build.admin should work right in here. Cloud Builder editor. Builder admin. I'm gonna stop murmuring to myself now. Cool. Right? And just go to manage access and have a bunch of roles. Look, these are all of the roles that are created. A bunch of roles added up. Right? Does it have owner? It has owner. Cool. Does it have cloud build admin or cloud build editor? Cloud build. There's no cloud build workpool, cloud functions. There's no cloud build editor or something, right? I'm going to go ahead and give them manually since it was right here with this cloud build.admin, but it might not work. So I'm just going to give it manually through here, which is cloud build admin. An editor is fine. Give it editor and cloud build admin. Is it cloud build.admin? If there is anything, any such thing, yep. So that's cloud build connection admin. I'll just do that. And I'll update the policy for that. You know what? I guess I'll just remove this. Right. What's wrong with you? Yeah. Now we gotta create the playground, right? And that's cluster. That's basically called a cluster, right? Let's just go ahead and create a cluster. So the name of the cluster is gonna be, let's say, I'm gonna call it MLOps cluster. And my zone, since it's a zonal cluster, is US Central 1A. The nodes are going to be 1 because this, my friend, is a dummy node, which we're going to, because since this is the default node, which is a scoped node, we want this, we literally want this to be deleted. We're going to create 3 extra nodes with scope cloud-platform. So that's the idea, right? We're going to create something with cloud-platform, right? Where is it? There you go, cloud-platform, right? So these nodes, right, will be able to access everything in the GCP domain, whereas this one node is a default node. It won't be able to access. It's a scoped node. It's configuring now. This is going to take time. All right, so it has run successfully, and machine type E2 medium. Yeah, but that's a pool, right? So I've created a default E2 medium. Anyways, on to the next step, right? On to the next step. So this is, by the way, a workload pool, meaning we inside this particular cluster will be able to give workload identity. Right? I will create a custom. Yeah, we will create a custom. So it's again my pool name. I'll just create as my pool, right? Cluster name is MLOps cluster. MLOps cluster. Zone name is 1A. And scopes are cloud platform, GKE, E2 small, 4 nodes of such and such types. We want these up and online. Let's see. So it's creating a node pool. Again, it's going to take a lot of time. So And it's done. So create a node pool, my pool, on to the next step again. Right, so we've got 4 nodes of each of 2 GB RAM, so probably 8 GB RAM and 8 vCPU cores. Right, let's just verify these nodes. Right, and so you have got 5 nodes, right? 4 of which are the ones we created by the name my pool, and 1 of which is default pool. Now we got to delete the default pool if you want to save your money. All right. Oh wow, we have created default pool and MLOps clusters. That's cool. I don't have to change anything, right? Yeah, the pool is deleted. All right, and I think I deleted the default pool, right? And I'm gonna switch context. Yeah, let's just do that now pretty quickly. And boom. MLOps cluster, the zone is what's the zone? US Central 1A, and the project ID. That's a variable, so no issues in that. Yep, and entry generated. So now the playground's ready, and it's called MLOps-cluster, right? That's the GKE cluster. Step 10, create namespaces, right? We need to create 2 namespaces, web and ML. Right, one for the web part, one for the ML part, right? Created. Cool. Now create an Nginx controller. Yeah, just clear that up. So remember the MLFlow thing that I was mentioning? So MLFlow is this thing here, right? The one that registers model and does everything. This is MLFlow, right? So even this one requires requires a public IP, and so I thought I'll use ingress of type Nginx, right? Or you can sort of make it service a load balancer. Anything is fine. I've done both. You can do anything, right? Anything is fine. What just happened? Right. So we were on to step number 11 now. We are creating this Nginx control. So to be able to enable this type Nginx, we need an Nginx controller with which we can sort of override the configs. And so we're going to create a namespace, separate namespace, which I haven't illustrated because it's not that necessary, but we've created this namespace and I'm going to apply that already, right? I'm going to apply that, and it's going to create everything in yep. Namespace is already configured and it's going to make this. Cool. And we're going to watch it, right? We need to get SVC. It's like a verification step, right? Services. I think the service name was, and it's not an ML, is it? Chris. Wait a second. Who's this? Controller. All right, it's up and running in the ingress-nginx namespace. All right. It's a type load balancer, and this is the external IP, but it's hitting nothing right now. So we will configure it later, but this is the external IP of it, right? Come on. Cool. So this is not a namespace ML, it's ingress-nginx. Look at the steps carefully. It says namespace ingress-nginx configured, right? The missing annotation will be patched automatically. So it does all of this for you, right? And it starts off this external IP for you as well. But what's the idea with this? That's a watch. Okay, that was the watch. If I just remove this watch, maybe it should work. Yeah, it just gives me the external IP then. So it's not a watch command. Cool. So step 11 done. Step 12. So now we're gonna move on to this. First of all, let me get my Git repo. By the way, I'm gonna give my Git repo and this file, the Notion file, right, with all the steps, all the explanation, and the Nginx file. Not the Nginx, sorry, the GitHub repo file. Everything in the link. I'll link it up in the description below, right? So let's just get the repo first. I'm gonna clone that. I'm just gonna do git clone this, and it clones that. And you remember, so we don't need this anymore, do we? Yeah, actually we do need this because since this is a demo, I'll be creating an empty repo, right? Imagine you cloned this and you're gonna push this repo after your changes, after all of your changes, you're gonna push this on your GitHub. So to demonstrate that, I'll make an empty repo. So just need this. Remember storing all the variables? Now we're gonna use all of this. Once everything gets cloned, we'll be using all of these variables according to the steps, right? I've basically mentioned everything in the steps, so it's fine. We were on step 12, git clone, and clone done, right? cd MLOps automation. Cool. Right. So now we are into this file, MLOps automation. Now, step 13, project structure. Yeah, this is actually a redundant step. It basically just explains that this is the YAML files for ML, YAML files for web, and this is a demo folder. So it's got nothing to do with the trigger and the pipeline. DB app, database versioning, sample data, so that's got nothing to do with us, with the pipeline. Web app, yes. MLFlow, yes. MLApp, yes. We've got a bunch of services. I can count 5, 6 services, but yeah. So step 14, change config maps of 1 and 2 and all the variables that you've stored. Right, so now this is going to come in use, right? Go to KHML, conf map 1, and you're going to create this MongoDB was demo, right? I'm going to create demo. Collections 2, which is my corrections, right? Right? My corrections bucket 1 is this. Right? It's my bucket 1. That's 2. And the third one, remember to keep the GS because, yeah. And the batch size and the train test split, I'm just going to keep it like this. But hopefully, this is it, right? So conf map 1 configured. Now, let's move to conf map 2. Conf map 2, my DB was demo, and collection 1 was my predictions. This correction. Figure that out. So that's for the web part, and that's for the ML part. Cool. Yeah. Step 15: change the KSAs in KHML and KHWeb folders, and change your service account. Right. So just go to this one, the KSA that you'll create. The KSA, like I said, will be binded to a GSA, so we'll have to give the service count, right? This. Cool. Inside the namespace ML, this one is the KSA is called ML-service-account. It's a service account, which means the KSA. Yeah, and for the web part, that. That. All right, that's the service account, and is the namespace web, the KSA name web-service-account in the namespace web, right? Cool. Case is configured. Step 16, change the image tags, right? You gotta change your, okay, just change the project ID and replace with your project ID. Let's get the project ID. The project ID is this. And I need to go to the cronjob, linear regression, all these different files. So cronjob, for example, I gotta change the image. I mean, this is gonna make no sense, sort of, because this is just a directory at the end of the day, and you can just keep everything as it is, it'll work. But then just to keep things clean, so that you recognize your own code, I'm gonna do this, right? This, by the way, is your tag, right? This will be when you apply an YAML file, it's going to take the latest image according to the hash of the build, and that's this variable right here, which is going to be used as a tag for the image that you build, right? And that is anything else. Do you want to change? I don't think so. That's the schedule, and that's the job, right? And namespace and cool. Linear score. I'm gonna take this. I'm gonna put it in here. Save that. Pretty cool. Should work. MLFlow ingress? No thanks. MLFlow? Yes. Anywhere we're building an image, we're gonna make this. Change this. Cool. Like I said, MLFlow will take these variables, right? These variables called, Postgre URI from secrets1 and bucket3 from confmap1 to configure. Well, this has already been explained in the video in the beginning section. So yeah, donezo. Same thing for the web part. Save that, change that. Right. cpf.yaml ingress, no. MLApp, yes. Save that. Prometheus config deploy service, nope. Restart, nope, because it's gonna use the same KSA, and so there's literally no change here, right? And by the way, I think I forgot to mention this in the video. I want to mention this. So this is, you remember we talked about the ML app in web? Where is it? The ML app, which loads the best model according to the experiment and the runs and the accuracies, just loads and keeps the best model with it. But what if there is a newer, better model? Then something has to restart this ML app. And the job that restarts this ML app is this. So every 7 hours, it restarts the ML app. It restarts, it is restart ML app. It restarts the ML app dash deployment, which is, which is basically this. It's going to restart this, and hence this one will, redeploy the image, and therefore it'll basically restart. It'll retake the best model. That's how it works. Yeah, cool. So 3 files in this and 3 files in this. Yes, right. 1, 2, 3 files in this, and yeah. Changed it. That's basically step 17, right? DB app, web app, and the KS, right? Then we're going to change the cloudbuild1.yaml file. So I'll tell you where. So in the cloudbuild1.yaml file, you got to change this everywhere, right? So all I'm going to do is, so let's just take this, and I'm going to change it with my project ID. It's this, right? Cool. Yeah, replace all. Right. Done. And save this up. Region, $cluster. Right. Everything works now. Cloudbuild2. Let's do the same thing. Yep. And replace that with this. Replace everything. Cool. Demo 477. Save that. So we've done that now. Okay, and then do the same thing with Cloudbuild2. Just change all the items of project ID. I hope I'm doing everything right. I think I'm not missing anything because pushing. sort of making, pushing, and then using. Using is just the same commands. You don't need to change anything there. Cool. Now we're gonna push the change repo. Wait a second, did I miss this? Yeah, create a GitHub repo. Yep, you cannot push until you make a GitHub repo. All right, so over to the next step, create over the next step is just create a Git repository. So I'll just be creating a Git repository. This is created, right? It's called demo MLOps. And so now we have to set the URL, right? So all we gotta do is do this and do git remote set URL of that, right? And so you basically have your origin now, and all you gotta do is git add dot and git commit dash m. Let's say in the repo according to my variables, right? Something like that, and then git push origin main, and hopefully it pushes everything into the repo. You cannot put a trigger. Actually, you can put a trigger in an empty repo, but the problem is there's no branch main. So you'll have to create a branch main which only exists if there's a commit. And so if you push a commit onto GitHub repo, right? So this is the commit, and therefore we basically created this branch main. Now we can put a trigger on this branch, right? Let's just follow the steps. We created the Git repo and we pushed everything to the Git repo. Now we'll just go to the trigger section. All right, cool. We'll just go to the trigger section. Gotcha. Okay, it was lost. You know what? Yeah, I'm gonna close that. I'm gonna put it here. So, go to the trigger section, and then you create trigger number 1. Just create this particular trigger, and I'm gonna call this, ML trigger because this is for the ML, so I'm just gonna call it ML trigger. It's global push to a branch, cloud build repositories, first gen repository, connect new repository, continue. So the thing is, my GCP account is on mail ID 1 and my GitHub account is on mail ID 2. So there was a problem in this authentication section, and it didn't show my GitHub account here because obviously it's linked to my other email ID, and therefore I had to sort of go here, I had to add, and it really didn't show me any clear option within, like for example, when you click add, it didn't really show me an exact option, but I had to log out and then log in, and then somehow it works now, right? So it shows my account. Repository is demo MLOps, right? I understand everything and connect. Right, global push to branch, first gen, select branch main. So this is my GitHub app. This is my branch main. And then go to show included and ignored files section. So that. And then type out all of this, right? So db app, my web app, and then .gitignore as well. Images folder that I just created, and the sample dataset folder as well. Why? Because all of this is right here. Data, this images and the sample dataset .gitignore and Cloud Build 2. If you're focusing on Cloud Build 1, then a change in Cloud Build 2 doesn't necessarily have to trigger the first pipeline, right? So that's why. So it basically is in, yeah, click the Cloud Build configuration file and Cloud Build configuration file repository. It's cloud build _1.yaml. You don't need to add variables. You need to send build logs, and my service account is my GS account, right? And I'll just go ahead and click create. Create a second trigger. I'm sure this is what it says, right? Create a second trigger called web trigger or whatever you like, but I'll just go for the name web trigger. And you can put in any name. First gen repository is the same repository. Branch is, why any branch? It has to be a main branch. Why any branch? What is this invert regions? Why does it show me my branch main? Any branch. It's okay, any branch, but it has to show main, right? Definitely does have to show branch main here, right? For now, any branch is fine, but it has to show a branch main. For now, it's fine. And show that. And so you're going to exclude everything that affects ML, right? Because if you want to focus on web, you got to ignore ML part, right? So all the folders, everything that has ML, yeah, you got to, you know, just ignore them. Just keep hitting enter, and you gotta add all of that, right? So all the ML part, right? So again, Cloud Build 2, any change in this file doesn't necessarily have to trigger build pipeline 2, right? So that's the idea. Yeah, that's a Cloud Build file, and we're gonna use _2 for that, right? It's not inline. You can go for inline, and you can sort of give your file in the editor here, right? In this editor. But anytime you want to change anything, you'll have to come to the editor. So it's better you do this, right? It's cloud build _YAML. And send build logs to Google, and your service account is my GKE account. Query that. So both of the pipelines are up and running. Set up the secrets in different namespaces. Cool, cool, cool. Let's take that. So this is the command that I'm basically just taking the commands and running, right? So we're at step 25 now. So we're going to create secrets 1 in the namespace ML and the Mongo URI, which we had created this right here. This is the Mongo URI. Wait a second. So this is the Mongo URI. So using the Mongo URI, my DB app will connect to MongoDB, and the cron job for the data pre-processing will also connect to MongoDB. And my PostgreSQL URI, which is this. /DB name. We've taken care of the end. And we will run this. And here, secrets 1 is created. And now time for secrets 2. all I gotta do is just copy this string and I'm gonna give it in here. Right. Cool. So secret store for web created. Now step 26, one push to trigger and create. So now you will be able to create, right? And so the idea is that, you know, that once all of this is up and running, once all of this is sort of up and running, the KSA that we created through the YAML file right here will also be up and running, and the KSA that we created in the web part, this one, will also be up and running. So you remember, if you do remember, KSA is a three-step process, right? You fire the KSA up and you bind it. Step 2 is binding it, right? And so this is where we've created the KSA, and this is where we've binded it with the GSA. Now step 3 is sort of authorizing, right? And so once all of this will be up and running, right, the KSAs will come online, and then we'll authorize and give it workload identity, and then we'll restart all the pods. That's the idea. So we were at step number 26, right? So one push to trigger and create everything, right? Let's see. Just go ahead and make a dummy commit, right? So that it triggers because it is push to trigger. This is a dummy commit. Dummy commit in this and a dummy commit here, right? Cool. And so all we gotta do now is create a dot and then they just call this dummy commit. Git push. And so this is the build, right? Here. And so now you should go ahead and see something in triggers in the history. So you can type triggers, you're in triggers now, okay? You're in triggers, and there in history, you should see something triggering, right? These two builds triggering. Yep. And you can get idea for both these builds in by clicking on the build icon here. This is the ML trigger and this is the web trigger. These two builds. This is my service account, manage access, this is my VPC. You can check a bunch of things, right? So you can check your Postgre, you can check your buckets, you can check a bunch of things. All right, I forgot one thing, and that is to create a folder within my bucket. So I'll just do that pretty quickly. Before this build runs, my idea is to go ahead and create two folders in bucket, right? Which I totally forgot. It totally missed me, right? I'll create a folder called version, all right? And then I also want to create a folder called InStream. Create that. All right. I think this was there in the step, and I think I missed it, right? Yep, the part where we create buckets. We had to create a version folder. Yes, too specifically with the name versioned and InStream. I did miss this. Usually you keep missing things, but you know, one small miss and everything goes crashing downhill, right? Let's just check the build. So I've reloaded the site and yep, it's done, right? You can see it's the same build. If you want, you can check the hash, it was 139F4, right? So 139F48A, right? So that's the commit. These are the last 7 characters of the commit. The build digit, the build ID is this. So hopefully everything is up and running. If you want, yeah, but now one thing is remaining, giving the KSA the workload identity, right? So that various processes will be able to use, or using the KSA, will be able to access buckets, right? So step 27, add this, the binding role, right? And so the idea is, after everything coming up online, you can see services up. Let's see if the services are up. But I guess many of them will crash because they're not yet connecting to the buckets. So yeah, including up your KSA. So the KSA is definitely up. And you mentioned K, it's in the YAML file. IAML workload identity user. Cool. So let's just give this now, right? And this is the command that we gotta run. So this is my email ID, my GSA email ID, right? So copy our GSA email ID into this command right here. And role is going to be workload identity user. Member is going to be my project ID that it to do, and namespace name and KSA name, right? So my project ID is this. My project ID, and the namespace name is gotta be, let's say we're making it for web, right? And the KSA name, have I mentioned everything or not? I guess I haven't mentioned. I'm gonna be mentioning everything. All right, I will be mentioning everything, but the KSA name for web is web-service-account. I'll be changing this file, right? So the next time you'll have is 2 commands here, right? So yeah, this web-service-account. Let's just run that up for the namespace web. Okay, everything looks cool, perfect. And it's created. You know what? Let me just open the Notion file. I'll sort of update that right now. That's the first command and the second command. So I think this is your GSA email ID. Yeah, I'll just call it your GSA email ID. Cool. And this is your project ID. So now you can just quickly run this. And the second thing is going to be for ML. And I think the name I gave to it was ML-service-account. You can just go to KSA and it's called ML-service-account. Cool. Run that up. Created. Let's just clear everything. Step number 27 done. Yeah, let's just, I'm gonna add that up. Right. Let me edit this really quick. Yep, and it's for ML, and it's ML-service-account. Run this command for both namespaces and be done with it. Done. Restart everything in both the namespaces, definitely. So I think, or do you want to delete everything in all the namespaces? Let's just go for delete. So that means everyone is using this local card called KSA, and we've sort of updated that. So you want everything to restart. So if you delete, Kubernetes automatically restarts everything, and then you sort of have refreshed. So it refreshes the information of the KSA. See, let me just quickly go ahead and delete all pods in web. And a bunch of things getting deleted, and but it's delete pods. It's not delete deployments. It's not delete services. it's delete pods, meaning these will come up again in a second or so. If it's delete deployment, then it won't come back up because it's not an ID, it's not an instance, it's the entire template that's running. Same thing for ML. Alrighty, let's just go for ML. And so it's sort of, so the idea behind Kubernetes is it deletes everything and puts back up everything online without changing the IP or without any downtime, right? Hopefully, if everything comes up, I'll be able to show you demo, right? I'll be able to show you how things change in the bucket and how this is a good MLOps project. Dunzo, so it's deleted. Now get the IP. Step 29 is what will the cron jobs do? They won't start immediately. Yep. So like I said, these cron jobs won't start immediately, right? The one that is data collection, this cron job, and the one that's training the model, right? Linear regression, and this won't start up immediately. So, but don't worry, I'll show you the entire demo. Get the IP of the web, right? So we want to get ingress dash and web because that was being accessed with the help of an ingress. All right, guys. To be honest, I had ran into a problem. The problem was really simple. Everything started up, ML app, the MLFlow, the web app, the predictions, everything was up. This one thing was not up. There was the web app. And the problem was here, right? In the ingress file of the web app, I've got something called webapp-ip, right? So I've created a static IP. I've reserved a static IP of, and it's called webapp-ip, right? So I forgot to create this thing called webapp-ip, and that is why the ingress was failing. It was not able to find anything called webapp-ip, and so actually I just went ahead and just added the step right here, right? You need to create a static IP called webapp-ip. I've created a step. I've basically added a new step, right? Create a static webapp-ip. It's called webapp-ip, and you can create that, right? I'll be fixing this file, right? But I've basically I've put the command that I forgot, right? And that was creating this webapp-ip, right? So I basically have this now. And if you basically run this command, I mean, since I had run this command later, I had to refresh all the nodes. But then if you run this command here, it would work just fine. Let's just go back to step number 30, right? So I've cleared everything, right? And my step number 30 is get the IP, right? We need to get the IP of the web, right? So just that command and run it. And so you'd get your address like this, right? So without the web app IP, this address was missing because it was not finding this pre-reserved IP called web app IP, right? And if you hit it, it works now, right? So we show all predictions. Right now, both the collections are empty, all right? And let's say if you want to predict something, right? What if we really want to, I'm just putting in dummy values, to be honest. What if you're just predicting something? This is my state and predict price. So it gives you 50,000. 50,000 is the default dummy model that's running. So meaning the model hasn't been trained yet. The model is not up and running yet, right? Let's just check that out really quick. Why is the model not up and running? State, yeah. Right, let's just get the Prometheus port. Let's just run command number, so step 31, and you get an external IP this, okay, for Prometheus. That's a load balance type, and hence an external IP. I'm just going to do that, and it's at port 1990. How do I know that? From here, it's running at port 1990, right? So hopefully Prometheus is also up and running. And we have MLFlow, right? So command number 32, which is this. Everything looks a little slow right now. Okay, we have the address, and this is at port 80. So this is for MLFlow. As you can see in models, there is literally no model registered yet. In experiments, we've got a default. Okay, the linear regression just ran, it seems. It's sort of running, I think. Yeah, I'll choose later. Is everything slow? Why are the servers slow? Okay, Prometheus has loaded. You can check the targets. And everything is up and running. Webapp, Prometheus, MLApp, and DBApp. Everything is up and running, right? And if you really want to query, if you really want to query in the graphs, you just go to the Notion file, and down below you have a bunch of queries that I put. So, for example, prediction request. This is one of these MLApp queries, right? By state as an experiment, if you want to do that. So, something over some period of time, right? So this is all the monitoring is up, and errors by type, average latency by experiment, current active requests. Let's look at the model load time in seconds, right? Which is basically why is it 0? So it hasn't queried anything yet, okay, for MLApp. So the idea is MLFlow, okay, which is it created an experiment, but there are no runs, meaning the cron job is still running, it seems. There are no registered models. We're going to come back to MLFlow in a second. We have Prometheus. We'll come back to it in a second. This is a dummy model for sure, right? Let's just go to home and let's see kubectl get pods dash in web, and everything is up and running. And what about kubectl get pods dash in ml? Okay, so it looks like linear regression job has got completed. But the idea is that it created an experiment called linear underscore regression, but there are no runs within it. Why are there no runs? Because probably it seems like the model didn't find any data to train on, right? And this is MLFlow that is up and running. Cron job has completed, but seems that the cron job hasn't found any data. So let's just do one. Guys, I made one more error, and the error is I had forgot to change the bucket names. God, I'm really ashamed today. I really forgot to change the bucket names. Everything was bucket one, take from bucket one, put in bucket one. Oh my God. Oh my God. So then I fixed it up and I've pushed it for a commit and I fixed everything that went wrong within my buckets now. All right. And all the services are just up and running as they were, right? Don't worry about this. It just create an experiment without runs because it didn't find any data to process on, like I said earlier. And the Prometheus is up and running. It's working. But this guy is a problem, right? So as soon as this builds, I'm gonna really show you a demo, right? I'm gonna put dummy data for correction. So, you know, some dummy data. Just to show you how the data flows through the network. And as soon as I predict, this is a dummy prediction, and I'm going to put the same thing now. I'm going to submit my correction, and done, right? And now, show all predictions. You've basically got this one that will be fed back into the model, right? But let it build again. Let the ML thing build. And by that time, all right, by that time, we'll go to bucket one. And you remember the sample data set, right, within the repo that we just cloned? Yeah, this data set. So right now we're programmed to take this data.csv as it is. Like it's programmed to look for data.csv, but you can change the program yourself later. And basically it has to be in this particular format. That's the main idea, right? So you should be able to create a folder. No, you should be able to upload a file called data.csv, right, within the sample dataset folder. And it has uploaded this. So right now, let this get built, right? But right now, our cron job, this guy has data from two places, right? One is this, and the second one is this, right? Your data.csv, and hence, once this gets built, we're going to create a one-time job, right? So a cron job is a template that spawns jobs on the basis of a particular schedule, and therefore we will manually create a single-time job, a one-time job that will be used for demonstration of how things work, right? Let's just clear it up. And so the command for that is going to be this one, okay? And the command is this one, which is, okay? And from cronjob slash ml-cronjob, which is the name of the cronjob, right? ml-cronjob. So this is the name of the cronjob, ml-cronjob-manual, all right? So this is to create a unique pod name, and we're gonna do that. So we're creating a one-time job in the ML namespace. Once everything comes up, so today there were two mistakes. Number one, I forgot to change the bucket names in conf map one, which is why I'm rebuilding that is why I'm having a new build. And the second mistake was I forgot to create something called the webapp IP, right? The webapp IP. So I've included the command for this, and hence that error shouldn't happen. And the cron job we're gonna make now. All right. I'll be back when the build gets completed. All right, so the build has completed, and I was just looking through the logs. Okay, so the build has completed. If you see kubectl get pods -ml should. So one is terminating, that was the old pod, and this one's the new one that's running. All right. So what about linear regression, right? So basically, back to where I was, it has basically, I'm going to reload this. Basically has this one collection, and in here and in bucket number one, it has this data.csv. Hopefully, when I create a one-time job, okay, called ML from ML-cronjob, okay, it should take the data, empty the bucket, and empty this collection, pre-process it, version it, and put everything into bucket number two. That's the idea. Let's see if this works. So it's creating the container for this guy, and it's running, and It's running. Give it a minute. Give it a minute. It's going to take the data, pre-process it, and put everything into bucket number 2. And it's completed. Now, when we should reload this, right, the collection number 2 is empty. Let's go to the bucket. Let's refresh this. And the data.csv is gone, so the bucket's empty. And if you go to bucket number 2, by the way, you remember the config map 1 where we said the batch size 50? The data.csv has more than 50 records, so it'll version all of that up into one version, right? It'll compile everything into one version, right? So if you go to bucket 2, if you go to version folder, it creates a version 1, all right? And version 1 basically has train and valid.csv according to the split size and the batch size, right? So that's the idea. So the cron job, the data pre-processing cron job, has been verified. What about the dummy model, right? It's still using the dummy model. And what about the model training and registration, right? I mean, there's no training done. Only the experiment has been created. But there's no training as such. So let's just spawn a one-time process. Let's just spawn a one-time cron job from this cron job linear regression. So we're gonna create a one-time job from the cron job template linear regression and give it a unique job ID. And let's just do it in the ML folder. So once that is done, it's created. And if you get the pods, right, it's creating. So this is the training. As soon as it sees a versioned data within this bucket, it trains it. Let's see if this works. And so container creating, it's a pretty heavy job, to be honest, because it's model training job, right? And it's running. And as you can see, the cron job has been completed. And if you look at the linear regression, it's running. Let's hope everything works fine. And it's completed. So for example, if you want to look at the logs, right? The idea is very simple. You just type this command kubectl logs, and you get this deployment or job name, and in namespace ML. By the way, I've given all of these commands in the Notion file, right? So it's already there. All these commands are available. And so look at the logs. The log is, it found no existing runs found, and it found an existing experiment, no existing runs found. It loaded the training data. It will train on version 1 to version 1. And it got the train valid.csv. This is the structure. That's the split. And it's going to train, right, on a bunch of samples. And it's logging everything. And training has been successfully completed. So we should be able to see it on MLFlow now. So this run name has been created. This run has been, confirmed. So the run has been created. The source, the model is train.py, right? Everything gets logged. And just directly go to the main. Just hit MLFlow. Right? You can go to models, and you'll see linear regression version 1, right? And so it'll basically automatically fetch up the best model. But guess what? The problem is my ML app, the one that runs the inference, has already loaded the dummy model that always gives me 50,000. But now we've definitely got a model, right, called version 1. So it has to be able to load that model first, right? So we'll have to spawn another one-time job, right, called restart ML app, right, whose name was restart ML app. So from this cron job template, we're gonna spawn one-time job called this, which will restart our stuff, right? So let's just do that. So we want to restart, right? So the command for that is here, right? And I want to restart, and the cron job name is restart MLApp. And basically MLApp. And the namespace is in web. Hopefully, this will also create a one-type job, right? And it's created. So if I want to get pods in web, yep, it's creating a container for this ML app restart, right? No, this is a container creating. Where is my restart app? It's running. Yep. So since this is running and this is restarting, I think it created a new container. This one should terminate soon, right? So that's the idea. Let's see what happens. Right. So this one got terminated. A new ML app is created. It runs the damn script again, and it loads the best model now. Right. And it's running, and this is completed, and the other guy is terminated. If you want to look at the logs now, right, the logs for the ML app now, right? If you look at the logs for the ML app now, it says, you know, it found a model called linear underscore regression. The accuracy is 71%, which is best so far. If there are a bunch of models and a bunch of accuracies from a bunch of runs and experiments, it looks at them all. And this is the run ID. And this is the accuracy. It loads the model from. This is the model ID, right? You can get it somewhere from MLFlow. And it successfully loaded it from the source path. Everything is up and running. So this time it shouldn't make any dummy predictions, okay? Because of the data that we fed it, it shouldn't make any dummy predictions. Let's see. Dummy prediction was 50,000, and technically, if you look at it, this is a one-type job that we spawn manually. Otherwise, it's going to run every 3 hours, right? So it's nothing to worry, right? Just and this is not a dummy prediction. Hence, the model is in running. So that was the idea, right? So you can keep using this app, right? You can keep correcting the predictions, and you can keep putting data into my bucket number 1, and it's going to keep retraining everything, right? And additionally, if you want to create a new model, all you got to do is go to this model, create a new folder called whatever model that you want, and have these many things in it, right? The train.py especially, and the Docker file, and make a YAML file to deploy the same cron job of type cron job. Okay, you can take a reference from this one, which is linear dash regression, and add a new step here, right? You don't need to make an image. Yeah, I mean, yeah, you do need to make an image, right? So you gotta add 3 extra steps: one to create, one to push, and one to use. That's it. So you make that many changes, and everything goes into running again, right? And this is the idea, right? And so if you want to run a few, so all the commands have been given here, right? They have been given here. And these are the kind of metrics. So for example, the store requests, right? The store requests total. I think they should come up in here. Store requests total. There have been 6 store requests total. I think we made 1 prediction latest, and then 2 corrections and 2 predictions, and so it's total 6 store requests. You can have and run a query if you want to. The query could be, for example, predicted price distribution, right? And this one comes from either, I think, MLApp or webapp. I think it comes from MLApp, right? And hit that. So what are the predicted price, variation in the last 5 minutes? This is PromQL, right? And this is the graph, right? So this is the variation. This is basically around 20K, 30K, whatever, right? So what is this? 1,075,000, that's the variation. So that was the idea, right? That was the complete working. There were only two errors that I made, and one was I forgot, and this is really funny, but I really forgot to put bucket 1, 2, and 3 in here. All of them were bucket 1, so I messed up everything in here. And number 2 is I forgot to add this step number 12, right? So I forgot to add the step number 12 called web IP, right? This step. So, and that is why it sort of gave an error on my web app ingress, right? Where I didn't find my web app IP. But now, since this is here, that shouldn't happen, right? So this entire code is reproducible. You can follow the steps as since I follow the same steps from fresh account, and you can deploy everything. Everything will be up and running. All the IPs are here, right? And it's running. So this is your MLOps project. It is self-evolving. It is really cool. It's sort of a beginner level project still, but it should be cool, right? And make sure to use these commands. That's all I would like to say. Make sure to use these commands. They help you. They help to give you, and especially this one, right? The kubectl logs, right? Because that literally gives you the print statements that the running code executes inside a pod, inside a container, inside a pod, right? So that's it. Hope you guys enjoyed it. Everything will be in the link below. The GitHub repo, this big README file, and yeah, that's all. Everything was follow along in this YouTube video. In the subject of MLOps, it's really hard to sort of create a non-error file. I mean, there are bound to be errors. There's one small thing, this one small error, and the cloud. On cloud, usually everything goes a failure. But hopefully, I made up, right? Hopefully, I made up. And thanks for watching.